Here's the thing, nature doesn't have a rulebook. It has 3.5 billion years of throwing random modifications at the wall to see what sticks. And some of what stuck was so profoundly weird that when scientists first discovered these creatures, their immediate reaction was essentially no, absolutely not. This can't be real. But it was real. These things existed. They hunted, they fed, they reproduced, they dominated their ecosystems. And they looked like something a sleep-deprived concept artist would get fired for creating. A Topodentatus was a marine reptile from the Middle Triassic, about 245 million years ago. When paleontologists first found its skull, they did what any reasonable person would do. They assumed it had a normal reptile head. Maybe a bit flattened, sure, but basically normal. They published papers. They made reconstructions. Everyone nodded and moved on. Then they found a better skull. Turns out Atopodentatus had a head that split vertically down the middle like a zipper. Its upper jaw was shaped like a hammerhead shark's head got compressed and widened, with the front edge lined with peg-like teeth. But the lower jaw, that split into two branches that curved outward, creating what looked like a biological rake. The whole apparatus was designed primarily for scraping algae off rocks in shallow marine environments. This thing would swim up to underwater vegetation, open its zipper mouth, and scrape the seafloor like some kind of Triassic vacuum cleaner. And it worked well enough that Atopodentatus became relatively common in its ecosystem, which raises an uncomfortable question. If this design was successful, what were the failed experiments? Speaking of failed experiments that somehow succeeded, let's talk about Charovipteryx. Most flying or gliding animals follow a pretty logical pattern. Birds have wings on their front limbs. Bats have wings on their front limbs. Flying squirrels have membranes that stretch between front and back limbs, but the control surfaces are mostly up front, where, you can steer with them. Charovipteryx looked at this perfectly sensible arrangement and decided to do the exact opposite. This tiny reptile from the late Triassic had enormous wing membranes attached to its hind legs, not its front legs. Those were small and basically useless for flight. The wings were on its back legs, stretched out behind it, like some kind of reverse delta wing configuration. Its front limbs were comparatively tiny, possibly used for grasping branches or just existing in a state of aerodynamic confusion. From an engineering perspective, this is insane. All your control surfaces are at the back of the aircraft. Your center of gravity is completely wrong. You can't make fine adjustments because you're basically steering with your feet while your arms flail uselessly up front. And yet it worked. We know it worked because Charovipteryx existed and presumably didn't spend its entire life faceplanting into Triassic shrubbery. Recent analysis suggests it might have glided at steep angles, possibly using its tail as an extra control surface and somehow making the whole backwards wing nightmare functional. Fast forward to the Miocene, about 15 million years ago. Elephants were already huge, widespread, and doing very well for themselves, with trunks, bulk, and social instincts that made them one of the most dominant animals on land. They had the formula locked in. Then Platybelodon showed up. Picture an elephant. Now take its lower jaw and flatten it into a massive shovel shape, like someone replaced its chin with a snowplow. Add 2 flat tusks to this shovel jaw, pointing forward and slightly downward. Congratulations, you've just created something that looks like a Photoshop mistake, but was actually wandering around Asia for several million years. Scientists have debated for decades what Platybelodon actually did with this bizarre adaptation. The shovel jaw was about 3 feet long, roughly a meter, and looked perfect for digging. But digging for what? Some researchers thought it scooped aquatic plants from lake bottoms. Others suggested it stripped bark from trees or excavated roots. Recent analysis of wear patterns on the tusks suggests it might have done all of these things, using different parts of the shovel for different feeding strategies. Modern elephants use their trunks for incredibly delicate manipulation. They can pick up a single peanut or uproot a tree. Platybelodon apparently said, "Or I could just have a built-in excavator on my face." The really unsettling part? Platybelodon wasn't even the weirdest shovel-tusked elephant. There were several different species in this group, each with slightly different shovel configurations, which means this wasn't a one-off accident. Having a snowplow for a lower jaw was a legitimate strategy, and it stuck around for a long time. Let's go back in time, way back, the Permian period, about 290 million years ago, before dinosaurs, before the worst mass extinction in Earth's history. The oceans were full of bizarre fish, many of which wouldn't look out of place in a horror movie. But Helicoprion would look out of place anywhere. For over a century, scientists knew Helicoprion existed because they kept finding these spiral structures made of teeth. Perfect spirals, like a circular saw blade made of shark teeth, getting progressively larger toward the outside. They called it a tooth whirl, and they had absolutely no idea where on the animal it went. The early theories were wonderfully absurd. Maybe it was a defensive spine on the back. Perhaps it was on the tail like some kind of biological morning star. What if it was just a shell and the whole animal lived inside the spiral? Turns out the whirl went in the shark's lower jaw, just sitting there, a rotating saw blade of teeth in its mouth. Helicoprion never shed its teeth like modern sharks. Instead, new teeth grew at the back of the jaw, and old teeth rotated forward into the whirl, creating this continuously growing spiral that could reach 18 inches or 45 centimeters in diameter in large individuals. The upper jaw was relatively normal, which made the whole thing even more bizarre. Just a regular shark head with a buzzsaw in its chin. Recent CT scanning of the best preserved specimens suggests the whirl sat back in the throat, and when Helicoprion closed its mouth, the spiral rotated backward, pulling prey deeper into the throat while the teeth sliced through it. Imagine a shark that swallows you and uses a rotating blade to process you on the way down. This design was successful enough that various species of Helicoprion persisted for about 40 million years. Pterosaurs, flying reptiles that dominated the skies while dinosaurs dominated the land, came in some pretty wild configurations. Some had wingspans rivaling small aircraft. Others had hundreds of needle-like teeth for filter feeding. But Nyctosaurus decided that wasn't weird enough. Nyctosaurus had a head crest that was literally larger than its entire body. We're not talking about a modest crest here. This thing had a structure extending from its skull that reached over 1.5 feet, around 55 centimeters, tall. A giant forked pole jutting up from its head like it was cosplaying as a radio tower. The animal's body length, wings excluded, was under 1.5 feet, around 40 centimeters. Its head ornament was significantly bigger than the actual pterosaur. When scientists first found these remains, many assumed they'd discovered a damaged specimen, or two different animals fossilized together, because surely nothing should be walking around with a head decoration that massive. The weight distribution alone feels like it should make flight impossible, but multiple specimens kept showing the same structure. Nyctosaurus really did fly around with a forked antenna on its head that dwarfed its body. The debate about what this structure actually did is still ongoing. Some researchers think it supported a membrane like a sail, used for display, or possibly even to help with gliding. Others argue it was purely for mating displays, like a peacock's tail taken to an absolutely ridiculous extreme. A few have suggested it might have helped with heat regulation too, though that feels like trying to justify insanity with science. Here's what we know for sure. Nyctosaurus could fly, despite having what amounts to a wind-catching billboard attached to its skull, and it was successful enough to persist for millions of years. Sometimes the most impractical-looking adaptations are the ones that work. Back on land in the Middle Triassic, Something was lurking in the trees that looked like nature got drunk and decided to combine a chameleon, a sloth, and a horror movie creature. Drepanosaurus was about 1.5 feet long or 45 centimeters, built for climbing, and equipped with adaptations that make you wonder if nature was just showing off at this point. It had a prehensile tail, like a monkey. That tail ended in a claw, unlike a monkey. It had massive curved claws on its hands that looked like something from a Tim Burton film. And its forelimbs were incredibly powerful, built for hanging from branches and probably tearing bark apart to get at insects. The claw on the second finger of each hand was particularly impressive, hugely enlarged, curved like a sickle, probably around 2 to 3 inches or 5 to 7 centimeters long on a 1.5-foot animal. That's like you having a 1-foot curved claw on each hand. For reference, modern sloths, which are significantly larger than Drepanosaurus, have claws around 3 to 4 inches or 7 to 10 centimeters long and use them primarily just to hang from branches. Drepanosaurus probably used its nightmare claws to tear open tree bark, hooking into wood while it searched for insects and grubs. Its powerful forelimbs could pry apart rotten wood, and its prehensile tail with the weird claw on the end provided extra stability and grip. Possibly that tail claw was used for additional purchase on tree trunks, or maybe for hooking additional food sources. We don't know for sure, because nothing alive today has quite this configuration. Tanystropheus had a neck that was longer than its body, and tail combined. Not slightly longer, not, oh that's a bit unusual, longer. Longer than the entire rest of the animal. In large individuals, the neck could reach 10 feet, or 3 meters long, made up of only 12 to 13 extremely elongated vertebrae. For comparison, giraffes have the same number of neck vertebrae as you do, 7. They're just bigger. Tanystropheus, however, has fewer vertebrae, but each one is a pool noodle. For over a century after its discovery in 1852, scientists assumed this thing lived on land. The logic seemed sound. Long neck, probably for reaching into crevices or high vegetation, similar to how a giraffe works. Every reconstruction showed it as a terrestrial animal, awkwardly moving around on land with this absurd neck, creating balance nightmares. Then, researchers actually studied the biomechanics and the environment where these fossils were found, and everything changed. Tanystropheus was aquatic, strongly associated with shallow marine environments. That ridiculous neck wasn't for reaching high branches. It was for ambush hunting in shallow marine environments. The animal would keep its body motionless and use its absurdly long neck to strike at fish, moving just its head through the water with minimal disturbance. Recent fossil evidence even shows fish scales in the stomach region of some specimens. The neck was relatively inflexible laterally. You couldn't bend it much side to side, but that actually makes sense for an ambush predator. You don't need to curl your neck around when you can just rotate your whole body. The nostrils were positioned high on the skull, meaning it could breathe while keeping most of its head submerged. So this thing would float in Triassic, shallow waters. This impossibly long neck extended, waiting for fish to swim by, then strike like the world's weirdest heron. And it worked well enough that Tanystropheus came in multiple size classes, from small juveniles to massive adults over 20 feet or 6 meters long, dominating their ecosystems for millions of years. When Charles Darwin was exploring South America in the 1830s, he found a lot of weird fossils, but one in particular stuck with him. A skeleton that looked like someone had assembled parts from completely different animals and hoped nobody would notice. Macrauchenia had the body of a llama or small camel. It had a trunk, not a full elephant trunk, but definitely an elongated nose structure based on the positioning of its nasal openings. Those nasal openings, by the way, weren't at the front of the skull where you'd expect them. They were positioned on top of the skull, between the eyes, like a hippo's, and it had three-toed feet that looked nothing like a llama's or an elephant's. Darwin literally wrote about how bizarre this animal was, how it seemed to combine features that had no business being together. Modern scientists haven't gotten much better at explaining it. Macrauchenia stood about 5 feet or 1.5 meters tall at the shoulder and lived in South America until about 10,000 years ago, recent enough that humans might have encountered them. It belonged to a completely extinct group of South American hoofed mammals that developed their own weird blueprint over a long stretch of time. And when a continent runs its own experiment long enough, things get strange. The trunk was probably used like a modern tapirs or elephants, for grasping vegetation, manipulating food, possibly for enhanced smell or making sounds. The high-position nostrils might suggest semi-aquatic habits, or they might have just been a quirk of skull structure. The three-toed feet were built for running on open plains, despite the animal looking like it should be slow and ungainly. Back to the Triassic again, because apparently that period was just a non-stop parade of biological absurdity. Longisquama was a small reptile, maybe 6 inches or 15 centimeters long, and it was covered in absolutely massive elongated scales running down its back. Massive as in some of these structures were comparable to the animal's entire body length, around 4 to 6 inches or 10 to 15 centimeters on a creature that small. When scientists first described these structures, chaos erupted. Were they feathers? Early wing-like filaments? Modified scales? Some bizarre display feature? The fossils weren't clear enough to settle it, which meant everyone could project their favorite theory onto poor Longisquama. Some researchers argued they were proto-feathers. Others thought they could have worked like gliding surfaces, though the mechanics of gliding with structures that long is at best questionable. The most grounded interpretation today is that they were modified scales used for display. Basically, this tiny Triassic reptile was running around with a decorative mane that looked completely impractical and somehow still worked for whatever job it was meant to do. We still don't have a definitive answer because Longisquama remains are rare and poorly preserved, but that hasn't stopped it from being one of the most argued over small reptiles in paleontology. Something about those elongated structures makes people lose their minds trying to explain them. Basilosaurus means king lizard. It was named in 1834 by Richard Harlan, who thought he'd discovered some kind of massive marine reptile. Then, scientists actually examined the teeth and skeleton properly and realized this lizard had mammalian teeth, gave birth to live young, and was warm-blooded. Basilosaurus wasn't a lizard. It was a whale. A very, very weird whale. This thing lived about 40 million years ago and stretched up to 60 feet or 18 meters long, making it one of the largest predators in its ecosystem. But unlike modern whales, Basilosaurus had a serpentine body shape, incredibly long and relatively narrow, like someone stretched a whale into a sea serpent. Its vertebrae were elongated, giving it a flexibility that modern whales lack. And here's the really bizarre part. It still had tiny, completely useless hind legs. These weren't vestigial nubs hidden inside the body like modern whales have. These were external, visible legs, complete with tiny feet, just floating there on the outside of the animal's body, about 2/3 of the way down its length. Each leg was roughly 1 foot, around 35 centimeters, long on a 60-foot animal. They were way too small to support any body weight and served absolutely no locomotion purpose. What were they for? The current theory is display or grasping during mating. They were just prominent enough and mobile enough that they might have been used to stimulate or position partners during reproduction. Basically, these limbs weren't there to help with swimming or walking. They were there for whale romance. The serpentine body, the mammalian head, the tiny dangling legs, all combined to create something that looked like it was designed by committee with no communication between departments. And it dominated the oceans for millions of years, proving once again that weird and successful aren't mutually exclusive. If you saw Arsinoitherium from a distance, you'd probably think rhino. Massive body, thick legs, big horns on the face. Close enough, right? Get closer and the problems start mounting. First, those horns weren't horns in the rhino sense. They were massive hollow structures made of bone, fused side by side on the animal's skull. Two gigantic hollow horns sitting next to each other. Some specimens showing horns over 2 feet or 60 centimeters long. Behind those, a second, smaller pair of horns. This thing had 4 horns total, arranged in 2 pairs. Second, Arsinoitherium wasn't a rhino at all. Despite looking like an oversized rhinoceros, anatomical analysis places it closer to elephants and manatees than to rhinos. It belonged to an entirely extinct group of mammals that lived in Africa during the Eocene and Oligocene between roughly 36 and 27 million years ago. The massive paired horns on the front of the skull remain one of the most debated structures. Hollow horns that size suggest they weren't primarily for combat. Solid horns would be more effective for that. The hollow structure made them lighter, which was important because Arsinoitherium was already hauling around a 6-foot tall, or 1.8 meter, multi-ton body. Some researchers suggest they were resonating chambers for making sounds, basically built-in megaphones for communication. Others think they were primarily for display, possibly growing larger in males for species recognition and sexual selection. A few have proposed they were used for combat, but in a specific way, clashing and pushing rather than stabbing, with the hollow structure allowing for bone flexibility that absorbed impact. We don't know for sure. What we do know is that Arsinoitherium had massive paired hollow horns. Multiple species carried the same basic weapon setup, and it looked like nature's attempt to create a rhino without ever having seen one. The resemblance to rhinos is honestly disturbing because these animals weren't close relatives at all. Same general size, same body build, same "I dare you to challenge me" energy. But Arsinoitherium went with 2 massive hollow horns, while rhinos used solid keratin horns. And somehow, both designs got the job done. This is Roaring Echo. Thank you for watching.